Welcome back to the final part of our tutorial on how to code the Among Us minigame using HTML, CSS and JavaScript. In the previous two parts, we covered HTML and CSS to create the structure and style of our game. Now in this third and exciting part, we'll be diving into JavaScript and adding interactivity and functionality to their game. So JavaScript is a powerful programming language which allows us to bring a game to life. We'll be using JavaScript to handle player movements, implement game logic, create an immersive gaming experience. Whether it's detecting player clicks, managing game stats, or implementing win conditions, JavaScript will be a go-to language for all these tasks. In this part of the tutorial, we'll start by introducing the basics of JavaScript, including variable, functions, loops, and conditionals. We will then apply these concepts to our game step by step, adding the necessary JavaScript code to make our game fully interactive. And by the end of this part, you'll have a deep understanding of how JavaScript can enhance the functionality and user experience of your projects. You'll be able to implement complex game mechanics, handle user input, create a dynamic, engaging game environment. So without further ado, let's get ready to bring our Among Us mini game to life with the power of JavaScript. So to start off, we will use jQuery for this. jQuery is a JavaScript library for DOM operations. It is very simple, fast, reliable, and it makes coding JavaScript a lot more easier. So just type in jQuery cdn.js in your Google browser and open up this first link, and from here we want to import the version 3.5.1 and just click this copy script tag. Open up your HTML and create a script tag and give it the source and paste the link. And just paste the link. So once we are ready with jQuery, we will now create a JavaScript file. So inside of the JavaScript folder which we had, we are going to add script.js and we will link the JavaScript file. So we give a script tag, the source to be static, JavaScript script.js. Make sure to save the HTML part and let's get started with the JavaScript. So to start off, we will call add document and dot ready will create a function we call in at modal class and we dot remove class hidden, after which we want it to go next task function. So this code is using jQuery to wait for the document to be ready before executing the code inside of the function. And once the document is ready, it removes the hidden class from any elements with the class modal and then calls the function go next task. So next thing we are doing is defining the function go next task. So we type in function go next task. We will add two variables. So where task called x array equals, we will create an array of numbers 500, 244 and 455. So this is the x and y coordinates which we are assigning as variables, and task called y array of 56, 56 and 90. After doing this much, we will create where index equals to, we will call in the class of nav button active dot index greater than equals to 0. Then we call nav button active once again. Right, so in this case the condition is at nav button active dot index is greater than equals to 0. This condition which checks if there is an active navigation button, and if there is an active navigation button, the value which is returned is nav button active index plus 1, which is the index value of the active button plus 1, and if there is an active button the value returned is 0. And the at nav button dot index method, so this method call, it will return the index of the active navigation button. The index method is used over here on the jQuery object nav button active, which selects all elements with the class of nav button active, and then the index method returns the index of the first element in the jQuery object, which is the index of the active navigation button. I hope that makes sense. If it didn't make sense, just watch this part again and it will be clear. Now we add if index is greater than 0, we call in map task dot eq index minus 1 dot add class of map task completed. And if index is equal to 0, so if index is equal to 0, we will set timeout function, and we'll create a function inside of it. in which we will call in the class of map character dot animate to top as 56 and left as 56. And we give the duration of it as 1100 and easing as linear. So this code snippet will check if the index variable is greater than 0, and if it is, it selects the previous element with the class map task and adds the class map task to it. So add class map task completed to it. Then the EQ method selects the element at specific index in the jQuery object, and in this case the index variable is used to specify the index of the element to be selected. The index variable is decremented by 1 to select the previous element, and the selected element is added to the class map task completed. So after having done this much part, when you start the game, your character, since you have done 0 tasks, so your character will move on to the first task. Then we create another set timeout. We select the class navbtn, and then we use the EQ method, give it index and add class of nav button active. And then we call in the class task EQ index, and we remove the class of hidden. After which we call in the function start task. All of this will be at 2100 duration, and all of this will be at 1000 milliseconds duration. So if index is equals to 0, all of this, else if index is equal to 4, we will select navbtn active and remove the class of nav button active. Then we select dot task class and we add the class of hidden. So add class hidden, then we select the map character, so map character dot remove class map character small. So we want to begin the game with not having the map character small class active, so the character will be of original size when we start the game. Map character small, and then we will animate the character. So we will select map character dot animated to top 156 and left of 674. We will set the duration to 2200 and add the easing as linear. Right, so what's happening in this section is that the jQuery code will select an element with the class nav button active at the specified index, and it will add the class nav button active to it. It will then select an element with the class task at the specified index and remove the class hidden from it. Duration of 2100 milliseconds, and this process will be happening after a delay of 1 millisecond. Else if the index is equal to 4, the nav button active class will be selected and it will be removed. The task will be selected and the class hidden will be applied to it, as you have already completed all the 4 tasks. The map character small will be removed by selecting the map character class, and the map character class will be animated to these coordinates in this much time using the animation mode easing as linear. Now once again we add the set timeout and we create a function in which we will select map character animate class. So map char dot animate we give it a top of 156 and left of 800. We give the duration for the same as 1800 milliseconds, and we will give easing linear once again. All of this will be happening at a time interval of 2200 milliseconds. So we set another set timeout function at 2200 milliseconds to animate the map character from these coordinates to these coordinates in 1800 milliseconds. And then we define else. So else if index equals to 4, execute all of this. Else we select the class navbtn active, which again is the class responsible for opening the task, and then we remove the class of navbtn active from it. Then we select the task class and we add hidden, and we add class hidden. After which we set a variable timeout and we assign its value as 0. Now we call in the class of progress completed, the modal which we designed earlier. We set its dot width as the index number times 25 plus percentage. And then we create a switch for the whatever the index number which we have. So we give index as the input in the switch, and then we create different cases. So first we start off with case 1, wherein we select if you're not getting this part, there is no need to worry. After typing all the cases, I'll explain it to you once again. So we call in the map character class and we add animate. So we animate it to top 56 and we give it a left of 244. We set its duration as 2700 milliseconds and easing linear once again. Then we time it out. So at this point the variable timeout will be assigned a value of 3700 and we break the case. For case 2 we have the same following code. So we select the map character, animate it to these coordinates in 3500 milliseconds with easing linear. Then we set a timeout function of 3500 milliseconds and wherein we select the map character, animate it to the next task. These are the coordinates of it in 1100 milliseconds. Then the timeout variable is set to the value of 5600. So after the second case, this will be the third case. So case 3, select the map character, animate it from to these coordinates in 1100 milliseconds. Then create another set timeout function for 1100 milliseconds to these coordinates once again. Create a set timeout function in which you select the map character and add the class of map character small, animate it to these coordinates in 2200 milliseconds, and the set timeout function is set at 3300 milliseconds. The timeout variable is given the value of 6500. After breaking it here, we will add a default and we will set the timeout value as 3000 and we will break this case. So what's happening in this bizarre section is that yes, so we are creating a switch. So the index is the number of the task which it was in. So first we select the progress completed bar, so the bar of the progress completed, assign its width, so the width to be incremented will be the number of task which is currently active times 25 and percentage the whole value. Then we create a switch in which we give index as the argument. If the case is 1, so if the value of index assigned in here is 1, select the map character and animate it to these coordinates in this much time using easing linear. If the value of index is 2, animate this character to this coordinate in this much time. If the case is 3, animate the character to this duration in to this coordinates in this duration, and add the map character small to map character class and animate it to this coordinate in this duration. So basically the character is moving around the map. And after we are done with all of this, we again set a set timeout, create a function, we call in the class of navbtn dot eq index, and then we add class navbtn active. So dot add class btn active. Then we select the class of task.eq index set again, and then we remove class hidden this time. And then we start and then we call function start task. At whatever the value of the variable timeout is over here. Alright, so this is what we have so far. So our character, since the value of index is 0, our character walks to the first task. Alright, so now we will first create the function of show task completed. So whenever a task is completed, the modal which was going to pop up. So we add function show completed task. The spelling is wrong. Yes. Function show completed task, in which we call in the class modal and we add class modal show. After which we create a set timeout, create a function inside of it wherein you will select the modal class and will remove the modal show. Finally, we call the go next task function and the set timeout will be at a duration of 1500 milliseconds. So what's happening here is that the show completed task function, in which the modal class is selected and modal show class is added, so the modal class is visible, and then the class will be visible for a duration of 1500 milliseconds, in which after which the class is selected and the modal show class is removed, and then the character proceeds to move towards the next task. After that much is done, we then select the nav btn so the class nav button is selected, and on click of the user we want to implement another function, which is if this here refers to the click. So if this has the class of nav btn active, you want to return the value of false. So return false. We create a where previous task in which we call in the class of nav btn active dot data, and the argument in dot data will be task. After then we select this plus the previous task which was mentioned above, and the closest task variable and the closest task class to it will be selected and will be added a class of hidden. Finally, we select the nav btn active, and we remove the class of nav btn active from it. After which we will select this, which is the click, and we will add the class of nav button active to it. And then again we will select, and then so we'll select class plus we will add this dot data task dot closest, then we will select the class of task again and remove the class of hidden from it. So remove class hidden. So this part of the code consists of lines which are executed when an element is clicked. The first line adds the class of nav button active to the closest to the clicked element using add class method, and then the this keyword refers to the clicked element, and the add class method adds the specific class to the element. And the second line will find the element with a class which matches the value of the data task attribute of the clicked element. Then the data method will be used to retrieve the value of data task attribute, and then the closest method will be used to find the closest ancestor element with a class of task. And finally, the remove class method is used to remove the hidden class from the ancestor element. So in summary, the code will add a class to the clicked element to indicate that it's active, and will remove a class from the related element to show it. This code is commonly used in navigation menus to show which page or selection is currently active. So after this much has been done, we will add clear timeout, and the input to it will be distributor timer. So the clear timeout distributor timer is a JavaScript function which cancels a timeout previously established by calling a new timeout and passing in the distributor timer variable. After which we will select distributor block active, and distributor thumb, and we will stop it. So this code will stop the animation of the element with the class distributor thumb, which is a child of the element with the class of distributor block active. And then after this much has been done, we will call in the function of start task. So the basic preparations of the game has been completed, and from here now we move on to coding the game. So first of all, we create a function start new task, start task. inside of which we will again create a switch, and the input will be the .nav button active, and we will add .data, and the input of it will be task. So inside of switch, the variable to check will be nav button active, of which the data is task. So if the case is returned as wires, we will call in the start wires function, and we will break the case. But if the case is shooting, we will call the start shooting function, and we will break the case. If the case is manifolds, we will start manifolds function, and we will break the case. Finally, if the case is distributor, we will call in the function start distributor, and we will break the case. For the default, we will just break it. So now let's start off by coding the wires section. First, we will start off by initializing some variables. So variable wires left offset will be equal to the offset of wires dot left. Same will be for the top. And we create a variable right wires. So the code initializes two variables, wires left offset and wires top offset, with the left and top offset positions of the dot wires element. So these positions of the dot wires element, if you still didn't get it, the offset left function is used to retrieve the left offset of this class and top offset of this class, right? And the at wire selector selects the wires elements. This selector, the at selector, it will select the wires element from the DOM, and the offset method returns an object containing the left and top offset positions of the element relative to the document. The left offset position is stored in the wire's left offset variable, and the top offset position is stored in the wire's top offset variable. After which we are going to call in the wires plus task refresh, and on click we implement a function, and the function is we call in the start wires function. So this code uses jQuery to bind a click event to a button with the class of task refresh, which is immediately preceded by an element with the class dot wires, and then the plus selector is used to select the next sibling element of wires element. So this is used to select the next sibling element of the dot wires element. Now we will need to create the function start wires. We call in wires left offset is equals to dot wires, and we extract the left offset of it. The same is to be done for top. Then we create a variable right wires indexes. So right wires indexes, and then we will create an array of 1 2 3 4, which will represent the 4 wires, and then we will shuffle this array. So shuffle the right wires index. So this code snippet uses jQuery to select the wires element on the web page, and get its offset position using the dot offset method. The dot offset method will return an object with two properties, left and top. The left property represents the horizontal offset position of the element relative to the document, and the top property represents the vertical offset position of the element relative to the document. The code snippet will then add the wires left offset variable to left property of the dot wires element's offset position, and will set the wires top offset variable to the top property of the dot wires element's offset position. I hope that makes sense. After which we will create variable underscore right wires, will create an empty array, and then we will create variable wire colors. So the possible colors of the wires, we will make an array of all the possible colors. So yellow, red, purple and blue. So the right wires variable is an empty array, and then we do write wires indexes dot map to a function item index. So what this has done is that the map method is used to create, so the map method, this map method is used to create a new array by calling a function on each element of an existing array. So in this case the map method is called on the write wires indexes array, and the function passed to map takes two arguments, item, which represents the current element being processed, and the index, which represents the index of the current element being processed. Inside of the function we will add variable this wire, and then we will call in wires back right, and we will call in wire nth child. Plus index plus 1, alright, and then this wire dot remove class, we will remove the class of wire yellow, and then remove the class of wire red, purple and blue. Wire red dot remove class wire purple, and dot remove class wire blue. And then we will add class wire underscore plus wire color item. So wire colors item -1. So the code block starts off, we are talking about this one. So the code block will start off by selecting a wire element from DOM using jQuery. The index variable is used to select the correct wire element based on its position of the list of wires. The index variable is then incremented by 1 to account for the fact that jQuery uses 1 based indexing instead of 0 based indexing. And then the selected wire element is stored in this wire variable. Next, any existing color classes are removed from the wire element using remove class method. This ensures that the wire element has no color classes before a new color class is added. Then the code block adds a new color to the class of wire element based on the array of colors called wire colors, this array. Then the item variable is used to select the correct order from the wire colors array. The item variable is decremented by 1 to account for the fact that arrays use 0 base indexing instead of 1 base indexing. So this is the important difference to keep in mind, that jQuery uses 1 based indexing while arrays use 0 based indexing. Henceforth, in this case 1 was added, and in this case 1 was decremented. And then the add class method is used to add new color class to the wire element, this add class. After which we will add underscore right wires dot push id as index plus 1, color as from the wire colors array. It will be item minus 1, position x will be from this wire dot offset, and the position y will be this wire dot offset dot top. Finally, we will have object as this wire. So the right wires push function, it adds an object to an array called right wires. The object contains information about a wire including its ID, color, position and object reference. The function takes 4 arguments: index, item, wire colors and this wire. Index is a number representing the index of the wire in array. Item is a number representing the color of wires. Wire colors is an array of colors, and this wire is a reference to the wire object. The function creates a new object with 4 properties. ID is the ID of the wire, which is the index plus 1. Color is the color of the wire, which is retrieved from wire colors array. Position x is the horizontal position of the wire, which is retrieved from the offset method of this wire object. And position y is the vertical position of the wire, which is also retrieved from the offset method of this wire object. And finally, the object is a reference to the this wire object. The function then pushes a new object to the right wires array, and then the right wires array is used to keep a track of the wires which are in the correct position or which have been properly connected. After which we will do right wires equal to underscore right wires, and then we will call in the wire class and remove class of wire active. Dot remove class wire set. and remove class wire correct and data connect. Data connected. Then we select the wire path class. We call in attribute D. This attribute is a part of the SVG, don't worry if you don't get it. And then we select the dot wire connector left. On mouse down, and we add a function with input E. So here first we set the right wires variable to a new value. The value of underscore right wires is assigned to right wires. Secondly, the remove class method is called on a jQuery object that selects all the elements with the wire class. The wire active, wire set and wire connect classes are removed from these elements. And then thirdly, we reset the connect data attribute to an empty string and resets the D attribute of all path elements to M00L00Z. This data method is called on the jQuery object that selects all elements with the wire class to set the connected data attribute to an empty string. This attribute is used to store information about which wires are connected to each other. Then the attr method is called on a jQuery object which selects all the path of the elements to set the D attribute to this M00L0Z. The D attribute is used to define the shape of the path element. So it is an SVG attribute. It is used to define the shape of the path element, in this case wires. And in this case the D attribute is set to a straight line that starts and ends at the same point, which effectively hides a path element. So how are we hiding the wire here? Is that the length of the wire starts and ends at the same point. So the wire is hidden. And then when we want to show the wire, the length will be adjusted accordingly. Inside of this function, we have if e dot which is not equal to 1, we want it to return false. So the if e dot which is not equal to 1 returns false statement will check if the left mouse button was clicked and returns the value false if it wasn't. So this is basically a clicking trigger for the left mouse button. We create variable wire equals to this. This is the click dot closest wire element, and then wire dot find wire body path. So wire body and path to dot attr dm35 and plus the wire dot index times 100 and plus 80. So all of this plus the L attribute plus the E dot page X minus wires left offset. Plus E dot page Y minus wires top offset. And then finally wires dot add class it is wire dot add class of wire active and remove the class of wire set. So remove the class of and dot data connected. This code is written in jQuery and is triggered by a mouse event. The wire variable is set to the closest ancestor element with the class of wire. The wire variable is set to the closest ancestor element with the class of the element that triggered the event. So the code then finds the path element with the class wire body, which is now a descendant of the wire element, and it sets its D attribute to a new value. The new value is a string that consists of the letter M followed by the coordinates of the starting point of the path and letter L followed by the coordinates of the ending point of the path. The starting point of the path is fixed at 35 on the x-axis and is calculated based on the index of the wire element on the y-axis. The ending point of the path is calculated based on the position of the mouse cursor on the page, with an offset subtracted to adjust for the position of the wire element on the page. So the code then adds the CSS class wire active, adds the class wire active and removes the class wire set from the wire element, and finally the code sets the connected data attribute of the wire element to an empty string. After which we call in document and on mouse move we add a function with input E. So the code document on mouse move wires function E. It uses the jQuery library to attach an event listener to the mouse move event on document object. The mouse move event is triggered whenever the mouse pointer is moved over the document, and the on method is used to attach the event listener and it takes two arguments here, the event to listen for and the function to execute when the event is triggered. So the second argument to on method is a function which is executed when the event is triggered. So this is the input and this is the event to be triggered. The function takes a single argument e, which is an event object which contains information about the event which was triggered. So what we do inside here is wire.find wire body path dot attribute d comma m35, so it's the same thing. I'll copy it and we set where connected equals to false. So the wire connection function is used to connect two wires in a circuit diagram. The function takes a wire object which represents the wire being connected and event object which represents the mouse event that triggered the connection. So the function first updates the D attribute of the SVG path element of the connecting wire. The D attribute is a string that defines the path of the SVG element. The M command moves the pen to a starting point and the L command draws a line to the new point. So the function sets the starting point to 35, comma wire.index times 100 plus 80 and the endpoint to e page x minus wires left offset, comma e page y minus wires left offset. The function then checks if the wire is connected to another wire. If it is not connected, the function sets the connected variable to false and returns. If it is connected, the function iterates through the right wires array, which contains information about the wires to the right of the connecting wire. For each wire in the array, the function checks if the wire is within a certain distance of the mouse event. If it is within a certain distance of the mouse pointer, the function updates the D attribute of SVG path to connect the other wire. So if the function also sets the connected variable to true and sets the data connected attribute of the connecting wire to the color of the other wire. And finally the function returns false to stop the iteration through the right wires array. In this whole code, the wires section is the most difficult to understand, but it's also easy once you get the hang of it. Alright, then we have the write wires dot map. Create a function with the input as item and if we call in math, we absolute the value of item dot position x minus wires left offset plus okay, there was a mistake. If math absolute item dot position x minus if math dot absolute item dot position x minus e dot page x (30) and math dot absolute item position y minus e dot page y. Item dot position y minus e dot page y plus 50 30. So if this condition is true, we want wire dot find, we want it to find wire body and path, attribute d m35 plus the wire index times 100 plus 80 plus L plus item position x minus wires left offset. Item position x minus wires left offset plus this plus item position y minus wires top offset plus 50. So item dot position y minus wires top offset plus 50 and we set connected equals to true and we return false. So the write wires dot map function is used in a web page to connect wires when the user clicks and drags a wire to other wire. The function takes an anonymous function as an argument which is called for each element in the write wires array. The function then checks if the mouse cursor is within a certain distance of the wire by calculating the absolute difference between position x and position y properties of the wire object and the page x and page y properties of the e object, which represents the mouse event. If the cursor is close enough to the wire, the function updates the path of the wire to connect it to the closest wire by setting the d attribute of path element inside the wire element. The wire's left offset and wire's top offset variables are used to adjust the position of the wire based on the position of the wire's container. The function also sets a data attribute on the wire element indicating the color of the wire it is connected to. The function also sets a data attribute on the wire element indicating the color of the wire it is connected to and sets the connected variable to true. The write wires dot map function returns false if the cursor is close enough to a wire, which stops the iteration over the write wires array. And then finally, if not equals to connected, we want wire dot data connected and then we call the check wires function. So this code snippet checks if the connected variable is falsy using the exclamation operator. If the connected is falsy, which means it is either undefined, null, false, zero, none, or an empty string. The code sets the connected data attribute of a jQuery object wire to an empty string using the data method. Then we select document.on mouse up. So in this case, the event bound is mouse up, which is triggered when the user releases the mouse button after clicking on element. The mouse up event is attached to the document object, which means that the event will be triggered when the mouse button is released anywhere on the page. If e.which is not equal to 1, return false. Wire.find wire body path attribute d comma m35 plus wire index times 100 plus 80 plus L attribute, then e page x minus left offset and e page y minus y offset. So this code sets up a mouse up event listener to the document object. The event listener is given the name wires.mu, which can be used to remove the event listener later if needed. When the user releases the mouse button after clicking on an element, the mouse up event is triggered and the function inside the event listener is executed. The function first checks if the mouse button pressed was left button, which has the value of 1. If it was not the left button, the function returns false and does nothing. If the left button was pressed, the function gets the path element inside the wire body element and sets its d attribute to a new value. The new value is a string that represents a path from current position of the wire to the position of the mouse cursor. The M command sets the starting point of the path and L command sets the end point of the path. The 35 value is the x coordinate of the starting point and wire.index times 100 plus 80 is the y coordinate of the starting point. The e.pagex and e.pagey values are the x and y coordinates of the mouse cursor respectively. The wire's left offset and wire's top offset values are used to adjust the position of the path based on the position of the wire element. Finally, we add at document of wires dot of mouse move up. Document of mouse move dot wires of mouse up comma wires mu. So this code removes event listeners for the mouse up and mouse move events on the document object. By removing these event listeners for the mouse move and mouse up events, the code stops listening for these events on the document object. This can be useful for cleaning up event listeners after they are no longer needed, preventing memory leaks and improving performance. We create where chosen wire equals to null and the right wires dot map function item. So we will now make a snippet that assigns a value to the chosen variable based on the position of the mouse click relative to the position of the wires on the screen. If the mouse click is within a certain distance of a wire, the chosen wire variable is set to that wire and the wire element is connected to the chosen wire element. If we call in the math library, if math.absolute item.position x minus e dot page x this is 30 and math dot absolute item position y minus e dot page y. This is e dot page y plus 50. This is 50. Now if this is 30, then so the if statement uses math.absolute function to calculate the absolute difference between the item element's position and the mouse pointer in both the x and y directions. The item element's position is represented by the position x and position y properties. The mouse pointer's position is represented by the e.pagex and e.pagey properties. If the absolute difference is less than or equal to 30 pixels, the wire is considered to be within the range of mouse click. The math.absolute function is used to ensure that the distance is always positive, regardless of the direction of the movement. And then this operator is used to check if the distance is less than or equal to 30 pixels in both the x and y directions. We add chosen wire equals to item and wire.data connected comma chosen wire.color. So the data method is used to set the connected attribute of wire element to the color attribute of chosen wire element. Then we do wire.find wire body path dot attribute I'll just copy it's the same attribute over and over again. So the code sets the D attribute of the path element to a string that represents a line between 2 points. The first point is located at 35 pixels from the left and 80 pixels from the top, plus an additional 100 pixels for each previous wire. The second point is located at the position x and position y coordinates of the chosen wire element, adjusted by wire's left offset and wire's top offset respectively, plus an additional 50 pixels from the top. Then we do return false The return false statement is used to break out of the map loop once a variable has been chosen. This is because the map method iterates over all the times in the right wires array, but we only need to find the first wire, which is within the range of the mouse click. And finally we wire.remove class wire active. Finally we do if chosen wire is not equal to null, then wire.add class wire set, else wire.remove class wire set, and find wire body path. Dot attribute M00L00, and then we call in the check wires function. So the if statement checks if the chosen wire variable is not null. If it is not null, it adds the class of wire set to the wire element. The wire element is a DOM element that represents a wire in the circuit diagram. The wire set class is used to indicate that the wire has been selected or highlighted in some way. If the chosen variable is null, the else block of the if statement is executed. This block removes the wire set class from the wire element and sets the D attribute of the path element inside the wire element to M00L00. The D attribute is used to define the shape of the path. In this case, the path is set to a straight line from 0, 0 to 0, 0, effectively hiding the wire. When a wire is selected, it is given the wire set class to indicate that it has been selected. When a wire is deselected, the wire set class is removed and the path is set to a straight line to hide the wire. And then to finish off the wire section, we create a function check wires. We call in wire pack left class and the wire class. So wires pack left class and the wire class dot each function variable correct right wire equals to right wires dot find rw, that is rw dot color, equal to this, which is the event dot data color. And if this dot data color is equal to this dot data connected is set to this is equal to this dot data connected then correct right wire dot object right wire dot object dot add class of wire correct. Else correct right wire dot object remove class wire connect. If wire connect dot length is equal to 4 dot length is equal to 4, simultaneously if wire active dot length is equal to 0, then show completed task. So let's understand this part. So this part uses jQuery to select all the left wires and it iterates through them using each method, and for each left wire the code snippet finds the corresponding right wire object in the array called right wires by matching the color of left wire with the right wire. If the color of the left wire matches the color of the right wire, the code snippet adds a class called wire correct to the corresponding right wire object. If the colors do not match, the wire correct class is removed from the corresponding right wire object. After iterating through all the left wires, the code snippet checks if all 4 correct wires have been connected and no wires are active. If both of these conditions are met, the show task completed function is called. If both of these conditions are met, the show completed task function is called. Now we move on to the so now the difficult part is over and now easy part begins. Now we move on to the shooting asteroid sections. So first we define a variable shooting left offset. So var this will be the horizontal offset of the dot shooting element. So we call in the class of shooting and then we extract the left offset. We do the same thing for top offset, so the vertical offset of the shooting element. Then we create a variable of asteroid counter. It is a counter for the number of asteroids which have been destroyed. So initially let's set the default value as 0. Then we need asteroid Q counter. So variable asteroid Q counter. We set it to 1. It is a counter for the number of asteroids which have been created. And then we need a max asteroid count. This is the maximum number of asteroids which can be present on the screen at one time. Let's set it to 5. And then we need a variable required asteroid number. This is the number of asteroids which need to be destroyed in order to complete the task, which is 20 in our case. And then we need a variable asteroid flying time. Asteroid flying time is the amount of time it takes for an asteroid to fly across the screen, which will be 3000 milliseconds. Then we need a variable asteroid status. So this is an array of statuses for each asteroid. Each status can be either idle or flying. So we create an array with all 5 asteroids being idle at once. And then we create a variable called asteroid interval. This is a variable used to store the interval ID for creating new asteroids. The next thing we start off with, we create a function start shooting. Asteroid counter equals to 0. And we declare the asteroid statuses. After which we add if asteroid interval is not equal to null. So if the asteroid interval is not equals to null, we want it to clear interval. So clear interval asteroid interval. Then we call in the shooting counter class. Dot text destroyed. And then we want to attach the asteroid counter number. Then we set the shooting left offset. So shooting left offset is equals to the offset which we will extract from the shooting class. So first we select the shooting class and then we extract the offset dot left in this case and dot top in this case. Then we select the class of shooting asteroid and then we use the each method and create a function in which we shall have this is the event dot stop and this dot css will modify its css to left at 600. Then we select the dot shooting asteroid wreckage and then we modify its css property to left as 700. Finally we call in a function called QAsteroids. Alright, so let's understand this. So the start shooting function is used to start a new game. The function resets the game state by setting asteroid counter to 0 and setting the asteroid status array to an array of 5 idle statuses. The function then checks if there is an existing asteroid interval and clears it if it exists. The function then updates the shooting counter text to display the current number of shooted asteroids. The function then gets the offset of the shooting element and sets the shooting left offset and shooting top offset variables to the left and top offset of the dot shooting element respectively. The function then selects all the dot shooting asteroid elements and stops any existing animations on them. The function will then set the left CSS property of each shooting asteroid element to 600 pixels. The function then sets the left CSS property of shooting asteroid wreckage element to 700 pixels. Finally, the function calls the QAsteroid function to start the game by queuing asteroids. Then we create a function QAsteroids and then we set asteroid interval equals to, so asteroid interval is equal to set interval, inside of which we create a function so if asteroid counter is less than required asteroid number, so if the number of asteroids destroyed are less than 20, Then variable asteroid is equal to shooting asteroid, and then we use the .eq method as asteroid q counter as input. And so if asteroid status is then we create an array is asteroids dot index equal to idle. Then you want to set the asteroid statuses as asteroid index equal to flies. So asteroid status is just as we did earlier. Dot index equals to flies, and then we send asteroids. We give the input as asteroid. Then we want to increment the value of asteroid q counter by 1. So asteroid q counter plus plus, and if asteroid q counter is equal to the maximum asteroid count, so if asteroid q counter is equal to max asteroid count, asteroid counter equals to 0. This will be happening at an interval of 1000 milliseconds. So let's understand this. So what's happening is that the q asteroid function, it sets an interval that runs every second and checks if the number of asteroid is less than required number. If it is, then the function selects the next asteroid in the queue and sends it if it is idle. The function first initializes an asteroid interval variable to hold the interval ID. The interval function checks if the asteroid counter is less than required asteroid number. If it is less, then the function selects the next asteroid in the queue using asteroid q counter variable. The function then checks if the selected asteroid is idle by checking its status in the asteroid status array. If the asteroid is idle, the function sets its status to flies and then sends the asteroid using sendAsteroid function. The asteroid q counter variable is then incremented. If it is equal to max asteroid count, it is resetted to 0. Here we create a new function. Here we create the function sendAsteroids, which we mentioned earlier. We will give it an input of asteroid. So asteroid.stop, and then we will give asteroid and modify its CSS properties. So first, the left property is modified to 600 pixels. The top property is modified to math.floor. math.random times 500, and then a variable end angle will be equal to math dot floor math dot random times 720. And then finally we create a variable top which is equal to math dot floor math dot random times 500. Let's understand this part now. So the send asteroid function is used to animate an asteroid object to move across the screen from right to left with a random angle of the rotation. The function takes an asteroid object as an argument, which is expected to have the following methods and properties. Stop. Let me just write that for you. The function takes an asteroid object as an argument, which is expected to have the following methods and properties. So the asteroid which we are defining here should have these properties. It should have stop, which is a method that stops the current animation of asteroid. Let me just copy them for you. It should have these properties. So CSS, it should have a method that sets the CSS properties of the asteroid. It should have animate, which is a method that animates the asteroid. It should have index, which is a method that returns the index of the asteroid in an array. The function will first stop the current animation of the asteroid using stop method. It then sets the CSS properties of the asteroid to position it at the right edge of the screen, and it gives a random vertical position using CSS method. The function then generates a random angle of rotation and a random vertical position for the asteroid. Next we add asteroid.animate and we give it a left of minus 100 pixels and a top of top. So the function animates the asteroid to move from right to left across the screen using animate method. The animate methods takes two arguments: an object that specifies the CSS properties to animate, and the second is an object that specifies the operation for animation. In this case, the CSS properties being animated are left and top of the asteroid, and the options for the animation include a step function and a duration property. We create step function, we give the arguments as now and fx. Then we call in this and modify its CSS. And modify its CSS. We set the transform to translate negative 50 pixels, negative 50% and negative 50%. We give it a rotate. We give it a rotate of end angle times now dot 700, now plus 100. which will be divided by 700 plus the degree. Then we set its duration as asteroid flying time, and we create a function, an empty function. So the step function is called for each step of the animation and is used to update the rotation of the asteroid. The step function takes two arguments, now, which is the current value of CSS property which is being animated, and fx, which is an object that contains information about the animation. The step function updates the transform property of the asteroid to rotate it by a random angle based on the current value of the left property. Then we create a set timeout and function. We give asteroid statuses, as asteroid dot index is equal to idle. And the time for the set timeout function will be the variable asteroid flying time. So in this part, finally the function sets a timeout to change the status of asteroid to idle after the animation is complete. This is done using the set timeout function. Then we select dot shooting plus task refresh, and we give dot on click. We give it a function that calls another function, start shooting. So this code selects an element with the class of shooting and then selects the next sibling element with the class of task refresh using the plus selector on the method. The on method is then called on the second element to add a click event listener. When the task refresh element is clicked, the start shooting function is called. Then we select the class shooting, and on mouse enter we create a function with the argument as e and set the variable cooldown as false. So the mouse enter event occurs when the mouse pointer is over the selected element. The mouse enter method triggers the mouse enter event or attaches a function to run when a mouse enter event occurs. Then we select the shooting cursor class and we modify its CSS property to top as e.pagey minus shooting top offset, and then again we modify its another CSS property of left to be e.pagex minus the shooting left offset. right? So the first line of this code selects an element with the class of using jQuery selector $, and the CSS method is then used to set the top and left CSS properties of the element. The top property is set to page Y property of the event object minus the shooting top offset variable, and the left property is set to page X property of the event object minus the shooting left offset variable. This positions the cursor element at the location of the mouse cursor. So we select the class shooting cursor rails, and then we find path dot attribute d comma m0500l plus the e.pagex minus shooting left offset plus space plus e.pagey minus shooting top offset. Plus L500 500. So what this done is that the second line, so the code selects an element with the class of shooting cursor rails. The find method is then used to select all path elements within the shooting cursor rails. The attribute method is then used to set the D attribute of the path element. The D attribute specifies the path data for the path element. The path data is set to a string that defines a line from left edge of the path element to the x coordinate of the mouse cursor minus the shooting left offset variable. Then the y coordinate of the mouse cursor minus the shooting top offset variable, and then to the right edge of the path element. This updates the path of the rail element to follow the movement of the cursor element properly. So wherever your mouse will move, the cursor rail will follow it precisely. Then we call in the class shooting, which we will have on mouse over, on mouse move dot smm. We call a function with argument e. So this code uses jQuery to add a mouse move event listener to all the elements with the class shooting. When the mouse moves over one of these elements, the event listener is triggered. So whenever your mouse cursor will move over an asteroid, whether you shoot or not, the event listener will be triggered and the function is passed to it is executed. Inside of which we select shooting cursor and we modify its CSS property. The top property will be set to e.pagey minus shooting offset minus shooting top offset, and then the same thing will be done for the left. So .css left will be e.pagex minus shoot y. Will be e.pagex minus shooting left offset. So this function will first select the element with the class shooting cursor and set its left and top property, as you can see here. Then we select the shooting cursor rails, and then we use find path, after which we will have the attribute d comma m0500l plus e dot pagex minus shooting left offset plus space plus e dot page y minus shooting top offset plus space plus e dot page y minus shooting top offset plus L 500. So this might look a little tough to understand, but it is absolutely not difficult. The function selects the element with the class shooting cursor rails and then finds all the path elements within it. It then sets the d attribute of each path element to a string that defines a path from the left edge of the shooting cursor rails element to the mouse position and back to the right edge of the shooting cursor rails element. This causes the shooting cursor rails element to display a line that follows the mouse as it moves over the shooting elements. After which we call in the class shooting and add event listener click. We name it sClick. And then we create a function with argument e, and we give if cooldown, then return false. So this code uses jQuery to add a click event listener to all elements with the class shooting. Whenever an element with the class shooting is clicked, the following function is executed. The function first checks if the cooldown variable is true. If it is true, the function returns false, which prevents the click event from being executed. If cooldown is false, the function continues. Cooldown is like the cooldown of a mouse, so you can't immediately click 2 times inside of the shooting section. You have to wait for a certain amount of time before shooting the second time, if that makes sense. Then we select the shooting explosion and modify its CSS property to top. I'll just copy it and modified CSS property top to e page y minus shooting top offset, left property to page x minus shooting left offset, explosion rotation to math.floor, math.random times 360 plus degree, and then we finally remove the class of hidden. So this function calculates the position of the click relative to the top and left offset of element with the class shooting. It uses these values to set the position of an element with the class shooting explosion. The explosion rotation CSS variable is also set to a random value between 0 and 360 degrees. The hidden class is removed from the shooting explosion element, which makes it visible. After which we assign cooldown variable to true, and then we create a set timeout and create a function inside it. Then we create shooting explosion, and we add a class of hidden to it, and then this will occur at an interval of 150 milliseconds. Then we create a set timeout function. Again we create a function inside of it, and we set its cooldown as false this time. And this will occur at an interval of 360 milliseconds. So what is the function of this part of the code? So in this part the cooldown variable is set to true, which disables the click event for 150 milliseconds, and the hidden class is added back to the shooting explosion element, which hides it. After that, another set timeout function is used to set the cooldown variable back to false after 300 milliseconds, which will re-enable the click event. After then we select document and we add an event listener. It is a click event listener. So click dot shoot, and we select the class shooting asteroid. And we create a function inside of which we declare a variable self, and we assign its value as this. So the click.shoot event handler function is triggered when a user clicks on an element with the class of shooting asteroid. The function then takes no arguments and uses this keyword to refer to the clicked element. Then we increment the asteroid counter variable by 1. So asteroid counter plus plus, and we select the shooting counter and we modify its text to destroyed, and then we add the asteroid counter variable to it. So You might have already guessed it, but this function will first increment the value of asteroid counter by 1, and then it will update the text of an element with the class shooting counter to display the new count of the destroyed asteroid. After which we select the variable self and we stop, followed by which we declare variable index to select self dot index. So the function will then stop the movement of the clicked asteroid using the stop method of jQuery object, and the function also gets the index of the clicked asteroid using the index method of the jQuery object. So now we want a function which will update the asteroid status array to mark the click asteroid as idle. So for that we just call in asteroid status says array index and we set it as idle. So this function will update the asteroid status as array to mark the clicked asteroid as idle. After which we create a set timeout function. So next the function uses set timeout method. The function which we will type, it will use the set timeout method to replace the clicked asteroid with a wreckage image. The function first sets the position and rotation of the wrecked image using CSS method of jQuery object. The function will then set the position of the clicked asteroid to move it off the screen. The function will then use another set timeout method to move the wreckage image to the right of the screen after a delay of 350 milliseconds. So we'll execute it just like this. Initially we will select shooting asteroid class, shooting asteroid wreckage, and we select the nth child. I'll just copy it for saving time for now. So the set timeout function is used to move an asteroid wreckage element to a new position after a delay of 50 milliseconds. The function will take an anonymous function as its first argument, which contains 3 chained CSS method calls. The CSS method is used to set the top and left properties, and transform CSS properties of the shooting asteroid wreckage element. The left and top properties are set to the same values as the left and top properties of the self element, which is the asteroid which was destroyed. The transform property is set to a random rotation between 0 and 359 degrees. after which we will select self, which is the current asteroid which the user has just clicked, and we will assign its CSS property to move it left by 600 pixels, and this will occur. This set timeout function will take place at every 50 milliseconds. So after the CSS method calls, the self element is moved off the screen by setting its left property to 600 pixels. This all is done to simulate the asteroid being destroyed and disappearing from the screen. The set timeout function is called with a delay of 50 milliseconds, which means that the anonymous function will be executed after 50 milliseconds after the set timeout function is called. We create that set timeout function, wherein we select shooting asteroid wreckage and its nth child. The number of which is max asteroid count plus 1 and plus its index. There will be no dot here. That appears to solve it, and we modify its CSS property to again move left, but this time by 700 pixels. And this set timeout function will occur every 350 milliseconds. So in this code snippet, the set timeout function is used to delay the execution of a function which sets the left CSS property of an element with the class shooting asteroid wreckage. The left property determines the horizontal position of the element on the page. The set timeout function is used to delay the execution of this function by 350 milliseconds. After that, we say if asteroid counter is equal to the required asteroid number, then we want the show completed task function to execute. So then here the if statement checks if the asteroid counter variable is equal to required asteroid number variable. If they are equal, the show completed task function is called and all the elements with the class shooting asteroid are stopped and moved to the right. Then we select the class shooting asteroid, dot each wherein we create a function. So the at shooting asteroid dot each function code will select all the elements with the class shooting asteroid and applies the each function to them. The each function will iterate over each element and will apply the function inside the code block to it. So here we select this and we stop all the activities. Then once again we select this and we move everything to the left by 600 pixels. So inside each function, the this dot stop code will stop animation of the current element, and this line will move the current element to the right by setting its left CSS property to 600 pixels. After that we select. So once we have done all this, the final thing which is left for the shooting section is we need a code snippet which will remove all the event listeners for mouse move, mouse leave and click events on the elements with the class of shooting and click events on the document. So for that purpose we will select the class of shooting and we will give on mouse leave and we will off this thing. We will disable the click, so we will off click.sClick. And then since we also want to disable click events on the document, we will select document and we will turn off click.sClick. So this event will remove event listeners for mouse leave, mouse move and click events on element and the document. Here we are done with our shooting part, and now we move on to our very last part, which is the manifolds. This one is actually the easiest of all the 4 tasks we have seen. So let's start off by declaring a variable manifolds counter, and we will give it a value of 1. Another variable manifolds block, and we will set it to false to begin with. Yes, so we start off by creating a function called start manifolds. Wherein we will give manifolds counter equals to 1. Then we will select the class manifolds button and we will remove it. So we select the class manifolds button dot remove. After which we will create an array for all the buttons inside of manifolds. We will name it mans and we will list all the numbers from 1 to 10. And after that we will shuffle this array, so we give shuffle and input we give as mans. After that we want to execute a for each function for mans, so we select mans dot for each, we create a function. The argument of the function will be item. So the start manifolds function is used to initialize a game of manifolds. The function first sets the manifolds counter variable to 1 and removes any existing buttons with the manifold button classes. Next, the function will create an array of numbers from 1 to 10 and shuffle it using the shuffle function. And the shuffle function is a custom function which will shuffle all the elements, after which we will select the manifolds panel class and we will append it. We will give in buttons. Start off by giving it a type of button. We will give it a class of manifolds button. Inside of which we want the item, which is the number of the manifolds, and we will close this button. So this will append a new button element to an element with a class of manifolds panel. The new button element is created using this code line right over here, where each item is a variable which contains the text to be displayed on that button. So 10 buttons will be created with each of these numbers on each of them. We made a mistake over here. Right over here we will have click dot shoot, so the shoot clicking events will be disabled from document. So we have made a mistake right here. What we wanted to do is select the class of shooting, and then on we wanted to give mouse leave dot smm, and we had to create a function inside of which this should have been. And yes, we are back on track. After which we will select document, and we will add an event listener for click events. So we will give in click, we want the manifolds button class to be selected, to which we will give a function the function which says if we give manifolds block. So if the manifolds are blocked, we want to return false, and if the manifolds counter, so if manifolds counter is not equal to this dot text, this is the again the array of numbers, and this represents a particular number from that array. So if it is not equal to the text inside of this, we want manifolds counter to be 1, and we will give manifolds blocked variable true. So manifolds blocked equals to true. After which we will select the manifolds button active, and we will remove that class from it. So we select the class manifolds button active, and then we remove the class manifolds button active. And then we will select manifolds panel class, and we will add a class of manifolds panel wrong. So when the wrong number is selected, we want to add the class of manifolds panel wrong. After which we will create a set timeout function, inside of which we will select the manifolds panel wrong, and we will remove the class, and we will set manifolds block variable to false again, which will occur every 500 milliseconds. So once you have selected the wrong number, the manifolds panel wrong class will be added, and after a interval of 500 milliseconds that class will be removed. We just have the same class, except we remove class manifolds panel wrong. And again we will set manifolds blocked variable to false. And this will occur at every 500 milliseconds, after which we will return false. Then the last part of the manifold section, we will select this, which is the current number button, and we will toggle a class of manifolds button active on that. So we give toggle class manifolds button active. So that button will be set to active, and the manifolds counter variable will be incremented by 1. Then to complete it, we will check if the manifolds counter is greater than 10. If it is greater than 10, then we will execute the show completed task. So we give if manifolds counter is greater than 10, we want to have the show completed task function. I guess this part was pretty much self-explanatory. So initially we start by assigning manifolds blocked as false, which means it's not blocked, and then we will check if the manifolds counter variable is not equal to the number inside it. So it's not equal to the number, it's not equal to the correct order of the sequence of numbers. Then we will assign the value of 1 to manifolds counter, and we will block that counter, after which we will remove the class of manifolds button active from it, and we will add manifolds panel wrong to manifolds panel. Then we will create a set timeout function to remove this class from manifolds panel wrong, which will occur at every 500 milliseconds, after which we will select the button and we will add a class of manifolds button active on it. If the sequence is correctly clicked, we will increment the manifolds counter by 1. Finally, we will check if it is greater than 10. If it is, then we will give the show completed task. What this part of code does is that the manifolds button click event handler is attached to a button with the class of manifolds button. When the button is clicked, the function is executed. The function first checks if a flag called manifolds block is set to true. If it is, the function returns false and does not execute further code. This is done to prevent the function from executing multiple times in a quick succession. If the manifolds flag is not set to true, the function will check if the manifolds counter variable is not equal to the text of the clicked button. If it is not equal, the function sets the manifolds counter variable to 1 and sets the manifolds blocked flag to true. It removes manifolds button active class from any element that has it and adds the manifolds panel wrong class to any element with the class manifolds panel. this is it, and sets a timeout of 500 milliseconds. After the timeout has elapsed, the function removes the manifolds panel wrong class from any element with that class and sets the manifolds blocked flag again to false. If the manifolds counter variable is equal to the text of the clicked button, the function does not execute any of the code inside the if statement and directly returns false. So the purpose of this function is to provide a feedback to the user when they click on a button. If the button clicked is not the correct one, then the function will add a visual cue to indicate that the user has made an error, and it will prevent the user from clicking on any other buttons until the timeout has elapsed. If the button clicked is the correct one, the function does not execute any further code and returns. And that brings us to our final task, which is the distributor. We will start by giving 4 variables: distributor number, which will be equal to 1. We will give distributor timer, we will create a variable distributor rotate time, and we'll set it as 3 seconds or 3000 milliseconds, and we will make a variable which will count the number of time it has been rotated. So variable distributor rotated counter, and we will initialize at 0. After then we will create a function start distributor, inside of which we will give distributor number equals to 1. And then we will select the class of distributor block, and we will remove the class of distributor block active. It will also remove the class of distributor block set. And finally it will select the class distributor thumb and will stop it. So the distributor function is used to start the distributor. The function resets the distributor by setting the distributor number variable to 1 and removing the distributor block active and distributor block set classes from all distributor blocks. The function also stops the animation of the distributor thumb and resets its position and rotation. Finally, the function enables the distributor button and launches the distributor. That part will come right here. So we want to select the class of distributor thumb, and we will modify its CSS property of margin right. Next we will modify the transform property to translate it by 0 pixel and -5 pixel. So translate by 0 pixel comma minus 5 pixels and rotate it by rotate this by negative 150 degree. After which we will select the distributor button class and we will give property disabled as false. And then we will launch distributor. So the distributor thumb element is the element that rotates when the distributor is launched. The function will stop the animation of the thumb by calling the stop method on it. The function will then reset the position of the rotation of the thumb by setting its margin right property to an empty string and its transform property to translate by 0 and negative 5 pixel and rotate it by 150 degrees, minus 150 degrees. The distributor button element is the distributor button. The function enables the button by setting its disable property to false. Then we will create a function launch distributor. We will clear timeout distributor timer. And we will set the distributor rotated count as 0. We will give the rotate time. Then we select the class distributor left panel and distributor block. And then we remove the class of distributor block active from it. After which we will select distributor block active. After which we will select distributor left panel and distributor block. And we select its nth child. The number of which is distributor number plus 1. And we add a class of distributor block active to it. After which we select distributor block active and distributor thumb. and we stop its animation. So this function first clears any existing distributor timer and resets its rotated count as 0. It then sets the distributor rotate time to 3000 milliseconds and removes distributor block active class from all the blocks in the left panel. The function then adds the distributor block active class to the block that corresponds to the distributor number variable. The function then stops any existing animation from distributor thumb element, and we have this line here which sets its margin right to an empty string. It also sets the transform property to translate the element up by 5 pixels and rotate it by -150 degrees. And then finally we will call the function start distributor rotation, and we will set the distributor timer as a set timeout function. The set timeout of start distributor rotation followed by distributor rotate time if greater than 0, then distributor rotate time as 3000. So what this line of code does is that the function starts the distributor rotation by calling start distributor rotation function. It also sets a new distributor timer using set timeout function. The timer is set to call the start distributor rotation function after distributor rotate time variable number of milliseconds. If the distributor rotate time is less than or equal to 0, the timer is set to 3000 milliseconds. We will then create a function called start distributor rotation. Inside of which we will clear the distributor timer. So we give clear timeout, distributor timer, and then we will select the block active and thumb element. And we will animate it by a margin right of 100 pixels. So this code uses jQuery to animate the rotation of an element with a class of distributor thumb. The animation is triggered by changing the margin right property of the element. The animation is executed using the animate function, which takes two arguments: an object containing CSS property to animate and an object containing options for the animation. Inside of here we will give a step of function with the arguments now and fx. We will give variable angle is equal to now divided by 100 times 360. So the step function is used to update the transform property of the element during the animation. The step function is called for each step of the animation and takes two arguments, now, which is the current value of the property being animated, and fx, which is an object containing information about the animation. Inside of the step function, the code calculates the angle of rotation based on the current value of the margin property. After that, we will select distributor block active. And distributor thumb. We modified CSS property to transform and translate it by moving up 5 pixel and its rotate to calculate minus 150 degree plus the angle and plus degree. We're missing a comma here. Something is wrong with the bracket placement, it seems. Alright, that seems to solve it. After which we will give if we will have math dot absolute We'll absolute the value of angle minus 120 if it is less than equals to 10. So the math.absolute function is used to get the absolute value of the difference between angle variable and 120. This will ensure that the difference is always positive regardless of whether the angle is greater than or less than 120. Inside of which we will select the class of distributor block nth child, let me just copy it for you to make things quicker. The add distributor block nth child distributor number 1. So this selector is used to select a specific element on the page. The distributor number variable is used to calculate the index of the element to select. The nth child selector is used to select the element based on its position of the parent element. And then finally we have duration. We set it as distributor rotate time. If greater than 0, distributor rotate time is 3000. And we give easing linear. We will complete this function. The function will select distributor block active and distributor thumb classes. And distributor thumb, and it will modify its CSS property. It will give, let me copy this again. It will set the margin right to an empty string and will translate it by 0 minus 5 pixel and rotate it by negative 150 degrees. And finally we will increment the distributor rotated count by 1. So the function sets the duration of the animation to distributor rotate time variable if it is greater than 0 or 3000 milliseconds. Otherwise, it sets the easing function to linear. When the animation is complete, the function resets the position and rotation of the active element's thumb and will increment the distributor rotated counter variable. After that, we will give distributor timer equals to set timeout, and we will have distributor rotation and distributor rotated time. So the first part takes a timer using set timeout function. The set timeout function takes two arguments, which are these two. A function to these are a function to execute a duration in milliseconds. In case the function to execute is start distributor rotation and the duration is distributor rotate time, the set timeout function returns a timer ID which is stored in the distributor timer variable. Here is it if you didn't understand it. Then for the second part, we will increment the distributor rotated count by 1. And then for its third part we will adjust some things. So we will give if count is equal to 1, we will give distributor rotate time as 4000 milliseconds. Else if distributor rotated count is greater than 1, we will give distributor rotate time as 6000 milliseconds. So depending on the number of times you have failed, the distributor time will get slower and slower, which will help you to click it easily. So the third part adjusts the distributor rotate time variable based on the value of the rotated count. If the count is equal to 1, the timer will be of 4000 seconds, and if it is greater than 1, the distributor rotate time is set to 5000 milliseconds. We will select the distributor button and we will add a click function to it. So we give on click, we will execute a function. So this function is a jQuery event listener which listens for a click event on an element with the class distributor button. When the element is clicked, the following function will be executed. This is the function. If this dot closest to distributor block, then we will extract its index number and we will clear timeout, the distributor timer. So it will check if the clicked element's closest ancestor with the class of distributor block also has the class distributor block set, and if the index of the ancestor element matches a variable called distributor number, and if both of these conditions are true, the block performs a series of actions. First, it will clear a timer called distributor timer. Then it will select the distributor block active and its thumb and will stop all the animations which are ongoing. And we will stop the existing animations. Afterwards, we will select these two classes and we will modify its CSS properties to transform it by 0 and -5 pixel and to rotate it by -270 degrees. After doing this, to end of distributors, we will finally increment the distributor number by 1, We will check if the distributor number is equals to 4. If it is, then we will call the function show completed task. And then we will call the function launch distributor, after which we will select this and we will give it a property, and its property disabled will be set as true. Else we will start the distributor over again, and we will select this and set its property of disabled as false. That brings us to end of all the tasks. But as you might notice now, the game still won't work properly. This is because we are lacking one very important thing. We are going to add what is called a Fisher-Yates shuffle algorithm. I'll copy it and explain it to you. So this is the Fisher-Yates shuffle algorithm, which is a very important part for this game. Without this, the game won't work. So the current variable is initialized to the length of the array. This is because the last index of the array is array length minus 1, and we want to start shuffling from the last element of the array. The temporary value variable is used to temporarily store the value of the current element which is being shuffled. The random index variable is used to store a randomly generated index within a range of the array indices. This random index is used to swap the current element with another element in the array. So to start off, this code snippet is typically used in a loop which iterates over the array from the last element to the first element. In each iteration, a random index is generated and the current element is swapped with the element at the random index. This process will continue until all the elements in the array have been shuffled. The while 0 not equal to current index loop will continue to execute as long as the current index variable is not equal to 0. If you want, I'll provide a video link in the description which greatly explains this algorithm. So we will leave at that and we will check if our game is working. So that brings us to the end of our tutorial. Make sure to subscribe for more tutorials. Till then, this is Codemeister signing off.